You've taken your neighbor's young child to the carnival to ride the rides. She wants to ride the Rocket. The Rocket has 8 rocket-shaped cars hanging by chains from the outside edge of a large steel disc. The vertical axle through the center of the ride turns the disc, causing the cars to revolve in a circle. You've just finished taking physics, so you decide, like a total nerd, to figure out the speed of the cars while you wait. You estimate that the disc is 5 meters in diameter and the chains are 6 meters long. The ride takes 10 seconds to reach full speed. Then the cars swing out until the chains are 20 degrees from vertical. What is the car's speed? So this is what the situation looks like. So we have our diameter disc here, we have our vertical axle, we have our little cars, our rockets here, we have our chain, which is 20 degrees from vertical, and we have our length of the chain here, and then we also have a time equals 10 seconds, but we're not going to use this, so we can kind of just scratch that. And make sure for this question that you have your calculator in degree mode, since we were given theta in degrees. So the first thing we need to do is to find the true radius of the rocket's movement. And so what we're just going to use simple trigonometry for this. So the true radius is going to be equal to the diameter of the disk divided by 2 plus the length of the chain times the sine of 20 degrees here. And so that's going to give us a true radius of 4.55 meters. Now we can worry about the velocity of the car. So the centripetal force, or just F, is going to be equal to the mass times the velocity squared over the radius. And we also know that F also equals the mass times the gravity constant times tangent of 20. And this is going to be kind of the weight of our car here. And so if the radius is 4.55 and we have the gravity being 9.8, we can kind of solve for what v is going to be in this situation. So we're going to set these two parts equal to each other, as we can see right here, and mass is going to cancel out. So we have v squared is equal to radius times gravity times tangent of 20, and we get that the velocity of the cars is 4.0285 meters per second. I'm guessing this is kind of a more kiddie car, but it's going pretty fast, I'd say. This sounds like a really thrilling ride. Our learning goals for today, and particularly this week, is uniform circular motion and forces. Considering that we are trying to find like the max velocity of the car, we're just going to go with a uniform circular motion. And we're also working with forces. And what we're also working on is trying to differentiate what pieces of information are important. Like when you first read this question, you think that the t equals 10 seconds would actually matter, but it actually doesn't. And then also you might look at these two equations separately and be like, oh, well, I don't have the mass, so I can't use that. You actually can, because the masses cancel out. So yeah, so that's question number 42. Thank you very much, and I hope you have a lovely day.